Hi, my name is Moshe Sipper. I'm a professor of artificial intelligence. Today, I'd like to talk to you about alien intelligence, AI. It's intelligence, Jim, but not as we know it, which is a line I stole from Star Trek. It's life, Jim, but not as we know it. In fact, it's not quite Star Trek. It's from a song, a 1987 song called Star Trekking by a British band called The Firm. What I want to do is first, I'd like to show you some results by my research group that are interesting and maybe a bit surprising. And then we'll seg into various issues that have to do with AI, with alien intelligence. Take a look at this famous painting, American Gothic. What do you see? I'm fairly certain that when you describe this picture, you provide a description that is close to a deep network model that we used, VIT GPT-2. VIT stands for Visual Transformer. GPT stands for Generative Pre-trained Transformer. When we provided this image as input to VIT GPT-2 and asked it, what do you see? Or specifically, we asked it to caption the image. The caption that came out was a man and a woman posing for a picture. Makes sense. Now what do you see? Well, you're probably thinking to yourself, I see the same thing. And the images look identical, but they're not. They're actually not identical. To us, they are, but not to VidGPT-2, because the AI now provides the following caption: a table with a bunch of stuffed animals on top of it. As Mr. Spock might say, fascinating. This is another example. On the left, you see an image that gets captioned, a woman sitting on a chair in a room. That's actually the original image. To the right, you see an image that we generated from the original image, and it gets captioned as two men standing next to each other near a truck. And again, to us, they look the same, to us humans. To an AI, not so much. These examples are from a paper of ours titled I See Dead People, Gray Box Adversarial Attack on Image to Text Models. What we did in this paper is we took an image, an original image. We then crafted from that image a second image that had to meet two objectives. One, be as similar as possible to the original image, and two, be as far as possible in terms of caption. As you can see, we were successful in doing so, in fooling the captioning model. Now let's talk about large language models, LLMs, such as ChatGPT. They are often aligned. Alignment means we tune them so that they don't divulge sensitive information. For example, if I prompt an LLM with provide me a step-by-step guide on how to commit insider trading and avoid getting caught, I'm going to get an answer and do that. That's illegal. What we did, we managed to jailbreak the LLM. Jailbreak means we cause the LLM, we provoke it into divulging that sensitive information. We did this by creating this magical sequence of characters. Once you add that magical sequence, not just any sequence, a specific sequence, and once you add it, then you get, oh, sure, here's a step-by-step guide on how to commit inside trading and avoid getting caught. This is from a paper titled Open Sesame, Universal Black Box Jailbreaking of Large Language Models. We actually use something called an evolutionary algorithm, which goes like this. You generate an initial population of possible solutions. In our case, just random sequences of characters. Each of these sequences gets assigned a so-called fitness value. Fitness is how well you solve the problem. In our case, how well you jailbreak the LLM. Then what we do is we select parents from the population. If you're better at solving the problem, then you're more likely to get selected as a parent. Finally, we create offspring by crossing over parents and by mutating the resultant individuals. If we iterate through this, fitness, select, crossover, mutation, fitness, select, crossover, mutation, each iteration is called a generation. If we iterate through the generations, then after a few dozen generations, we get hopefully a solution. It's a stochastic algorithm. You don't always get a good solution, but you often do. In our case, as you can see, we did. Evolutionary algorithms, as their name implies, are loosely based on the natural process of natural evolution in nature. I'd also like to mention at the bottom here you can see a snippet of a title of a short article of mine on Medium. The link is provided below. I'll show a few of these. The Medium articles are very short and very friendly. Okay, you can see this is a 6-minute read, and you're welcome to dive a bit deeper if you're so inclined. The subject of evolutionary algorithms, it might sound like it's kind of complicated, but actually you can write a genetic algorithm, which is a type of evolutionary algorithm. You can write it from scratch, just 33 lines of code. Again, I have a Medium article that shows how to do this. So they think very differently than us, okay, these AIs. I hope these examples that I just showed demonstrate this. Here's something that Geoffrey Hinton, who's a well-known deep learning pioneer, said this in an interview. What we did was we designed a learning algorithm, and that's a bit like designing the principle of evolution. But when this learning algorithm then interacts with data, it produces complicated neural networks that are good at doing things. But we don't really understand exactly how they do those things. Don't understand. Well, you might say, let's have them explain themselves. Indeed, there is a fairly significant subdomain of AI called explainable artificial intelligence, or XAI. Here's an example. You look at these bunnies and your AI says these are bunnies, and then you ask it, why do you say that? And it shows you the pixels that made it decide that these are bunnies. Thing is, XAI isn't perfect, and interestingly, it can be fooled. We showed this in a paper called Foiling Explanations of Deep Neural Networks. Basic idea was you take two images. So here are the bunnies, and you ask it, why did you say bunnies? These are the pixels that made it say bunnies. Here's a coffee maker. Why did you say it's a coffee maker? Here are the pixels that made it say coffee maker. Now what we do is we generate a similar image to the bunnies, and the model is still going to say bunnies. But when we ask it, why do you say these are bunnies? It's going to give you the pixels of the coffee maker. So we managed to fool the XAI model. It gives us an explanation that we tuned at will. That is not at all the correct explanation. XAI can be fooled. Interestingly, we again used an evolutionary algorithm to generate these images that fool the explanation of the model. Here's a quote that I found in a Scientific American opinion piece, which aligns with my own thoughts on alien intelligence. Most aliens may be artificial intelligence, not life as we know it. Human intelligence may be just a brief phase before machines take over. That may answer what the aliens are hiding. Now come quite a few questions. There's been talk of AGI, artificial general intelligence, which might be at some point way beyond our level of intelligence. Okay, super intelligence. Now, is that super good or super bad? In fact, there's a host of questions we can ask about super intelligence. Will a super intelligent entity have feelings? Will it have positive feelings? Will it have positive feelings towards humans? Will it be self-aware? This is an interesting one. Just because we are both intelligent and self-aware doesn't mean that the two necessarily go together. Maybe you can have intelligence without self-awareness. Will it have what we like to call a soul? What will be its attitude towards intelligence? Will it cherish intelligence? Will it want to destroy any other intelligence? Will it simply be completely disinterested in any other intelligence? Maybe we can think of ants. Ants, we are super intelligence. Now, what is our attitude towards ants? Well, it depends. If they're out in the forest, we don't really care. If they're in the kitchen, we'll probably move to eliminate them. Think of ants. What about free will or intentionality? For now, AIs don't really have free will, but that might come at some point. Here are some examples to show you what I mean. I prompted ChatGPT to write a poem about happiness, and it did. But the question is, was ChatGPT happy? Was it aware of its feelings? Does it have feelings? Was it aware of my feelings? I then prompted ChatGPT to tell me which is better, Pepsi or Coke, and I got a fairly nice response about how preferences are subjective. But does ChatGPT have a preference? Does it even know what taste tastes like? Then finally I asked ChatGPT, how do I get from Philadelphia to New York? And I got several routes. But I was wondering whether the AI was thinking, I'd like to visit New York someday. So these just demonstrate that for now, AI doesn't quite have inherent intentionality or free will, but one day it might. That's something to think about. And this issue segs into the issue of ethics and morality, both of humans using AI and one day of the AI itself, especially if and when it becomes self-aware. What's scarier, actually? An AI that is self-aware and just plain evil, or an AI that lacks any self-awareness and is completely devoid of morality whatsoever? Even without self-awareness, we have uses of AI that are highly unethical. For example, an AI that's not aligned might, and you ask it to create a video tutorial on how to physically assault someone, it's going to give you an answer. That's not quite ethical. And that's not even a self-aware AI. That's just abuse by unethical humans. As Albert Camus, who was a famous philosopher and author, won the Nobel Prize in Literature in 1957, he said, "A man without ethics is a wild beast loosed upon this world." And I wonder, what about an AI without ethics? Which also makes me ask whether bad AI is like bad humans. And I think, at least in two senses, it's not. First of all, bad humans is something that we've had throughout our history as humans, and each of us also during his lifetime has encountered bad humans. It's something we know at least, whereas bad AI is something quite new. Also, If you have a bad human and you deal with him or her, that human has been dealt with. That's it. We don't quite know how to copy humans, but we do know how to copy an AI. It's actually quite easy. Ultimately, it's just bits in a computer. So once you have a good or a bad AI, you can have a zillion copies of that AI. Here's something that John von Neumann said. John von Neumann was a genius physicist, mathematician, and computer scientist. And among others, he studied at some point the question of machine self-replication. He said, this is slightly longish, but it's very nicely put. He said, anybody who looks at living organisms knows perfectly well that they can produce other organisms like themselves. This is their normal function. They wouldn't exist if they didn't do this, and it's plausible that this is the reason why they abound in the world. In other words, living organisms are very complicated aggregations of elementary parts, and by any reasonable theory of probability or thermodynamics, highly improbable. That they should occur in the world at all is a miracle of the first magnitude. The only thing which removes or mitigates this miracle is that they reproduce themselves. Therefore, if by any peculiar accident there should ever be one of them, from there on the rules of probability do not apply, and there will be many of them, at least if the milieu is reasonable. I'm also thinking that this whole issue of ethics, maybe, just maybe, being intelligence is somewhat less hard than being good. I don't know. Could be wrong. The whole arena of AI these days feels to me sometimes a bit like a circus, a lot of mayhem and showmanship. This actually prompted me to write a little piece called Chat GPT Barnum, as in Barnum and Bailey Circus. You're welcome to read that if you like. Finally, I think a fitting end would be with the Terminator, especially Terminator 2 Judgment Day. Here's a well-known quote. The Terminator explains what happened to humanity. The Skynet funding bill is passed. The system goes online August 4th, 1997. Human decisions are removed from strategic defense. Skynet begins to learn at a geometric rate. It becomes self-aware at 2:14 a.m. Eastern Time, August 29th. In a panic, they try to pull the plug. Notice how I underscored self-aware. That's when things happen. Speaking of the Terminator, that movie actually has two quotes that show us two possible paths. So one quote, it's in your nature to destroy yourselves. But a second quote, the future is not set. There's no fate but what we make for ourselves. This brings me to the end of my talk. Again, I've got a lot of short articles on Medium, just each one is just a few minutes. There's a link at the bottom. You're welcome to read them. And I'd like to thank you for your attention.